Mass causes gravity. That's why everything in the solar system revolves around the sun, as it's the most massive thing around. However, a new study posits that gravity can exist without mass, which turns both our understanding of Newtonian physics on its head and raises new questions about the existence of dark matter.
Hey everybody, and welcome to Studio 64. My name's David. I've been searching the interzones for some more science, space and tech news to share with you. And I came across this over at Science Alert. This should be very interesting. Now, there's a wild new study that suggests that gravity can exist without mass. Wow. Okay, this should be interesting. That's a very nice image. Fascinating. Yes, now what is gravity without mass? Both Newton's revolutionary laws describing its universal effect and Einstein's proposal of a dimpled space-time, and we've thought gravity is exclusively, within the domain of matter. Now a wild new study suggests that gravity can exist without mass, conveniently eliminating the need for one of the most elusive substances in our universe, dark matter. That's interesting, isn't it? Yeah, as usual, I'll leave the link to the main article below the video so you can pop in, check out the embedded links, go for a bit of a deeper dive beyond the main article if you like. Makes for a very, very interesting read, believe me. And as I say, I'm not a scientist myself, but if there are any physicists out there, feel free to comment on the video because I'd love to hear from them. It'd be great. I just love sharing science and news stories. Science news stories. I'm a student of all sciences, whether it's physics, astronomy, marine biology, material science, chemistry, whatever. I just love all science. It's just, I love sharing it with people. Dark matter is a hypothetical invisible mass thought to make up 85% of the universe's total bulk. Now, originally devised to account for galaxies holding together under high-speed rotation, it has yet to be directly observed, leading physicists to propose all sorts of out-there ideas to avoid invoking this elusive material as a way to plug the holes in current theories. Okay. Now, the latest offering in that vein comes from astrophysicist Richard Lu at the University of Alabama in Huntsville, who has suggested that rather than dark matter binding galaxies and other bodies together, the universe may contain thin shell-like layers of topological defects that give rise to gravity without any underlying mass. Okay. Lu started out trying to find another solution to the Einstein field equations, which relate to the curvature of space-time to the presence of matter within it. Now, there's a little video here that's on the new theory posits gravity can exist without mass from a maze lab. Let's check it out. It goes for about a minute and a half, and then we'll carry on the conversation when we come out the other side.
Mass causes gravity. That's why everything in the solar system revolves around the sun, as it's the most massive thing around. However, a new study posits that gravity can exist without mass, which turns both our understanding of Newtonian physics on its head and raises new questions about the existence of dark matter. Experts believe that dark matter likely makes up some 85% of the universe, but we have never observed it, meaning it is basically the only thing we can come up with to account for all of the extra gravity holding galaxies together. However, a new theory from astrophysicist Richard Lu suggests that instead of dark matter, topological defects in the universe might increase gravitational connectedness without the associated mass. Lu was initially attempting to solve a version of Einstein's field equations, saying he was driven by his frustration with the status quo, namely the notion of dark matter's existence, despite the lack of any direct evidence for a whole century, saying instead his calculations revealed shell-shaped topological defects that manifest in particular areas of space with extremely dense amounts of matter. These shells contain positive mass inside a layer of negative mass, canceling one another out. However, when a massive object like a star rests atop it, it gets dragged inward. Lu says it may not be a smoking gun for the death of dark matter, but adds it's the first solution with mathematical proof that gravity can exist without mass.
Well, that was really interesting. I enjoyed that. That was amazing. This stuns me, the things that we're coming up with. Absolutely amazes me. As I said, I'm very jealous of people who are that incredibly smart that they can understand this sort of stuff. It just fascinates me. As Einstein described in his 1915 theory of general relativity, space-time warps around bundles of matter and streams of radiation in the universe, depending on their energy and momentum. That energy, of course, is related to mass in Einstein's famous equation E equals mc squared. So an object's mass is linked to its energy, which bends space-time. And this curvature of space-time is what Einstein described as gravity, a notch more sophisticated than Newton's 17th century approximation of gravity as a force between two objects with mass. Now, in other words, gravity seems inextricably linked to mass. Okay. Not so, posits Lou. Okay. In his workings, Lou set about solving a simplified version of the Einstein field equations that allows for an infinite gravitational force in the absence of any detectable mass. He says his efforts were driven by my frustration with the status quo, namely the notion of dark matter's existence despite the lack of any direct evidence for a whole century. Now, Lou's solution consists of shell-shaped topological defects that might occur in very compact regions of space with a very high density of matter. Now, these sets of concentric shells contain a thin layer of positive mass tucked inside an outer layer of negative mass. The two masses cancel each other out, so the total mass of the two layers is exactly zero. But when a star lies on this shell, it experiences a large gravitational force dragging towards the center of the shell. It's basically like a star stepping on a Lego. You ever stepped on a Lego? You get a gravitational force dragging you towards the floor. Yeah, so I say it's similar to that. The contention of my paper, not trying to diminish this guy's work with jokes, but that's what pops into my head. A Lego, yes, bringing the universe down. Fascinating. The contention of my paper is that at least the shells it posits are massless, Lou says. If those contentious suggestions bear any weight, then there is no need to perpetuate this seemingly endless search for dark matter, Lou adds. Now, the next question then is how to possibly confirm or refute the shells that Lou has proposed through observations. Now, the increasing frequency of sightings of ring and shell-like formations of galaxies in the universe lends evidence to the type of source being proposed here, Lou writes in his paper. Now, although he admits that his proposed solution is highly suggestive and cannot alone discredit the dark matter hypotheses, it could be an interesting mathematical exercise at best, Lou concludes, but it is the first mathematical proof that gravity can exist without mass. That's fascinating, isn't it? Use your words, David. You're running on a quarter of a Fetterman or half a Biden this afternoon. Your brain, Jesus.
Why the hell would I take a test? Come on, man.
The study has been published in monthly notices of the Royal Astronomical Society. Yes, the Venerable Royal Astronomical Society. That's fascinating, isn't it? I wonder what Einstein or Newton would have to say about that. Gravity can exist without mass. That's absolutely fascinating. Yeah. What do you think? Do you think it's possible? Love to hear from you, especially if you're a physicist or mathematician. That'd be fantastic. Really appreciate it. Thank you. All right. Well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video. I'd love to hear what you think. All right. Take care. And as I always say, if you can't be good at it. And as I also always say,
my brain hurts.